Hi, this is Dr. Alan Barnard, CEO of Goldman Research Labs. It's a great honor to present this masterclass in theory of constraints today for the group from MediaTek. I'd like to focus on two questions that I've been asked to share my insights and vision to. Firstly is why should all businesses and also TOC practitioners use digital technologies more? They are a key part of Industry 4.0. I know that many businesses in Japan, including Daiwa House and MediaTek and other partners, have been using digital technologies. But why should that probably be accelerated and be focused on even more to bring more value to customers, to shareholders, as well as to managers and employees? And the second question is, why should IT managers and engineers study theory of constraints in total, not just the CCPM part of theory of constraints? So let's start. Why change? Why should we fully capitalize on the power of digital technologies that form part of Industry 4.0? Well, there's three reasons that I'd like to share. The first one is that when you are comparing those firms or companies that have fully adopted technology, the top 5% of companies within every industry, they are normally outperforming their counterparts that have not made those type of investments by an order of magnitude. Sometimes it's 5, 10, 15, up to 50% differences in productivity and profitability than their partners. And that's true not just for industries with high digital intensity, but also for industries with traditionally more lower digital type of intensity. So you have to be very concerned not to be left behind. The second reason reflects our human nature. We know that many of the failures that we see in our businesses, many of the delays that are caused, many of the quality defects are due to human error. For example, 60% of all shortages is due to an overall underreaction by the human beings, the buyers and sellers, not due to forecast error. 65% of surpluses are due to overbuying or overproduction, not due to forecast error. 70% of data loss and hardware failures are due to human error, only 11% due to hackers. 80% of airplane crashes are due to human error, not equipment failure or weather. 90% of car crashes due to human error, not equipment or computer failure. And human error in medical diagnosis and treatment is now the third leading cause of death. So if this is true, then should we not consider using digital technologies like AI to make all important decisions? Well, I will share with you what my recommendations are a little bit later, because there are definitely some decisions that we should use technology for and others that we should not. There's a third reason, which is we are looking at a fourth revolution, industrial revolution, that is giving companies access to a whole basket of exponential technologies. Each one of them could potentially overcome major limitations within the company and as a result deliver exponential increases in productivity, in speed, in quality, and ultimately in value to customers, to shareholders, and its employees. These technologies include autonomous robots or vehicles, big data, and AI for analytics, augmented reality, additive manufacturing, cloud computing, cybersecurity, industrial Internet of Things, system integration, simulation, but to mention a few. There are others like blockchain and quantum computers that are extremely exciting. When we are using these to solve real-life business problems, they can generate an exponential growth in the value that you can provide to customers, to shareholders, to employees. And obviously, this has been in the news a lot, and as a result, expectations have changed. There are very high expectations of these technologies. Unfortunately, in reality, many of these expectations have not been met. For example, globally, business leaders, 35% of them expect that these technologies would enable them to grow their revenues by at least 20% over the next 5 years. 43% expect these technologies to help them lower costs by more than 20%. And 56% expect that these technologies will bring an overall efficiency improvement of more than 20%. Unfortunately, those results have not been proven in many of the companies and industries. I'll present a case study of how you can try to analyze what is going wrong and maybe gain some insight into what's going wrong using one of the theory of constraints tools that I developed called the ProCon Cloud method. So what to change? Dr. Eric Goldrat wrote a very famous book called Necessary But Not Sufficient, in which he presented an hypothesis that said technology is necessary. Necessary for what? To unlock more value and more productivity improvements, but it will likely not be sufficient. Why is that? He highlighted two principles. He said that technology or service can bring value if and only if it diminishes a limitation. But before that technology existed, people had to live with it. So how did they live with it? They developed some kind of coping mechanism and rule to help them live with the limitation. And he asked two simple but very important questions. What value, if any, will the technology bring if it does not diminish a valuable limitation for the user or for the company that is using that technology? Whether this is AI and cloud computing or driverless vehicles, or you have to check, does it actually diminish a valuable limitation for that company? If not, you can't expect it to bring value. But secondly, what are the rules that were put in place to live with that previous limitation? Because if these rules are not changed, you are not going to be able to fully exploit the power of the technology. For example, in mining, the fact that human beings have to go underground and mine means that the mine tunnels have to be designed in a way that will comfortably accommodate human beings, including the height of the tunnels as well as the level of oxygen that has to be down there. What if you could put robots to do the mining? Some you don't need the ventilation, at least not to the extent that you need for human beings. And secondly, you can change the height, reduce the height of the tunnels dramatically, which will be a massive cost saving and allow you to get in exactly where you want the ore to be mined. But if those rules are not changed, when you're putting in the new technology like robots, you're not going to get the full value of the technology. Dr. Goldrat presented his insights in the form of 6 questions that you could use to ask whether any technology, including the list of these Industry 4.0 technologies, should we expect them to bring value? And if they should and they don't, why is that? What is the real power of the technology? What limitation can this technology diminish for users? And what is the value of diminishing this limitation for the users? The more valuable the limitation is, the more valuable the technology will be that overcomes that limitation. But then the question number 3, what rules did you put in place in the past to accommodate that limitation? Because if you don't change those rules to new rules that allows you to fully exploit the power of the technology, you can't expect the full value. Question number 5, if you're not getting the value, maybe it is because people keep on going to the old rules. So is it not possible to implement these new rules in the technology itself to prevent people from going back to the old way? And lastly, if you're still not seeing the value, it could be that there's a problem in the business model. Maybe the partner that is paid to implement the technology gets paid in the wrong way. And as a result, they sell you technology that's not that valuable, or they take way too long to implement it because they get paid on the time it takes them to implement it. So this is a very useful framework for these new digital technologies. And I would highly encourage that you constantly is helping your business identify what technology is most likely to overcome a major limitation, what rules that need to be changed, and then does it deliver the value? And if it's not delivering the value, use this framework as a way of identifying why not and how to change it. So what to change? How can we combine the power of these new exponential technologies that's coming with Industry 4.0, things like simulation, things like cloud computing, quantum computing, robotics, AI, big data? How can we combine all of them with the power of theory of constraints, a set of rules that help us to optimize the system rather than just parts of the system? Well, we can use the technology to automate repetitive work that wastes management employee time and attention, our scarcest resource. Repetitive work can be demotivating, And we need to release capacity for people to do meaningful work, to do the type of work that only human beings can do, problem solving, creativity, etc. So that should be the first part of your journey towards digital transformation, is to go out to all your employees, ask them to complete a questionnaire. What are the type of work that you do that is repetitive, that should be automated? What are the type of work that you do that you find meaningless and a waste of time? Should that be stopped, or can it be automated if it is required? That's a great way to create a pool for the technology to really involve the people in checking where will it diminish limitations. Then the second one is, of course, can we use technology to prevent avoidable and consequential decision mistakes? So I want to share just briefly 4 types of avoidable decision mistakes that we know and have good experience that technology can help us overcome it. The first one is dealing with what is commonly known as VUCA, environments where there's lots of volatility, there's lots of uncertainty, complexity, constraints and ambiguity in the targets that you're trying to achieve. There's trade-offs. So we put people into these positions, into these environments, and then we ask them to make decisions. Well, as human beings, we have a real limitation. We cannot fully consider all of these elements, all the uncertainty, and especially those non-linear dependencies where small change can have a big impact. We can't fully consider that when we make decisions. So what did we do? We developed some coping mechanisms. We use an assumption that if it's good for my part, if it's good for the local part, it's good for the system. Or if it's good for the short term, it should be good for the long term. But often that results in local or short-term optimization. So people local and short-term optimize, not because they're trying to harm the system, it's often because they just can't fully consider the full impact of changes on the system. Can we use technology to overcome this limitation? Secondly, we make avoidable decision mistakes when we get overwhelmed. We face many decisions every day. We multitask, we get decision fatigued, and we get overwhelmed. So how do we cope with that? Well, when we get overwhelmed, suffer from decision fatigue, we tend to go towards the safest option, which is often not changing anything, or maybe coming up with some compromise. And that blocks us from adopting these new technologies. Is when people are so overwhelmed, the last thing they want to do is to adopt a new technology because they're already overwhelmed. So if we can find ways of automating the things that can be automated, maybe that will release the capacity and the motivation for them to adopt some of these new technologies. The third avoidable mistake we make is we have a real challenge when we make decisions, in that we don't fully understand to what extent our emotions impact our decisions. We think we are very rational when we make decisions, but in fact, we are very emotional. We make a decision and then we find a way of justifying the decision. We don't look objectively and then we decide. So how do we cope with this? Is we often just go with our gut feel, and our gut feel can cause us to overreact, but it can also cause us to procrastinate due to the many psychological and cognitive biases that we do have. So we need to find a way of using technology to overcome these strong emotions, to help us to discover limiting assumptions and belief, and help us develop new options. And then the last part is we often put people into environments where they don't yet have the experience and intuition, because it takes a long time to develop that. It's often up to 10,000 hours to develop the intuition to make these type of difficult decisions. So how do we deal with that? We give people just rules to follow, but computers can follow rules. So that's not very useful, and it often causes people to follow rules when they shouldn't. Or they simply ask an expert if they don't know, but that causes expert resource bottlenecks. So how do we deal with these 4 issues? Well, the first one with VUCA. Today, we've made advancements in simulation modeling that we can simulate or create digital twins, not just of simple pieces of equipment or business process, but of full companies and full supply chains. And I'll show you an example of that. When it comes to fatigue and overwhelm, you really should be encouraging everybody to participate in this, to say what are the type of tasks that they do that is repetitive, that is not meaningful, that can be done by computers, and automate those tasks, use technology and use it as a way of releasing capacity, creating capacity so that people can focus on meaningful work and decisions that only human beings should do, things that require problem solving, creativity, coming up with new options. How can we use technology to overcome this limitation that we often use emotions to make decisions and not so much our logic? Is we have at Golden Research Labs developed a Procon Cloud method and a Harmony Decision Maker app, and I'll show you a brief case study. This is something that you should develop as a skill, the ability to identify what is the conflict below a problem that has remained unresolved, what's the assumptions or beliefs that is limiting you from resolving that conflict in a new win-win way, and to develop new options. So I'll present a brief example of that and highly encourage everybody to learn how to use the Procon Cloud method and a Harmony Decision Maker app. And then lastly, intuition gaps. Can we use, for example, AI, not to learn from data, but to learn directly from the top experts? We've partnered with a company that has done that, and they've developed a technology called Tom. If you are interested, you can go to up2tom.com. So UP, the number 2, and then tom.com, where you can use AI to learn from the top human experts within your company and make that knowledge available to novices. So let me quickly go through a few case studies. So the first one is can we use the theory of constraints rules and embed that within a technology like SAP to dramatically improve the performance of the company? Implementing just the technology like SAP will not by itself bring value unless you use it to automate rules that are already good rules. If you can use it to change rules to global optimal rules, best practices from theory of constraints, that will unlock a lot of potential. So in this project with Microsoft, we used the 6 questions of necessary but not sufficient to say for their SAP implementation, what's the power of SAP? It can be used to process, store, and retrieve large amounts of data quickly and accurately. What limitation does the technology diminish? And what's the value of that? As managers at all levels often have to make decisions without all the relevant data or without the ability to predict what the impact will be of their system. That is a huge limitation and could cost the company millions and millions of dollars if we get it wrong. So how did we live with this limitation? How do managers live with this limitation? Well, they often develop their own offline systems to support their own business needs and decision making using Excel. But that means often the main IT system like SAP does not get updated. It doesn't have access to all these the data in these offline systems. So it becomes sort of a self-fulfilling prophecy where people say that the system is not accurate. They develop their own systems offline, and as a result, they don't update SAP, and therefore it remains inaccurate. But managers also use local or short-term optimal rules to accommodate this limitation. For example, pricing. We set a standard price for a product and assume that we show you the standard cost. If you sell it below the standard cost, you'll lose money. If you sell it above the standard cost, you'll make money. But of course, that's not true in many cases, in that our variable cost is a small percentage of the total cost. So if we do have the capacity, as long as we get more than the variable cost, it'll be profitable. At the same time, even if our price is way above our standard cost, if we don't have the capacity and it starts hurting the performance of other orders that we've already committed to, we might end up losing money on an order that we think is profitable. So we need to figure out what these old rules are and how to best replace them so we can use the SAP system to tell us whether to accept an order or not based on the consequences. What's the new rules? Can we use theory of constraints, for example, and use SAP to implement and automate theory of constraints, which is what we did in this project to manage their whole global supply chain, both for make to order, assemble to order, as well as make to stock or make to availability. And then set up the accounting system to support throughput accounting so we can quickly see what the total impact will be on throughput, investment, and operating expenses to make sure that we make good decisions for the system as a whole. And then was there any changes that we made in the technology? We decided to embed these rules inside of SAP to make it very difficult for people to go back to the old rules. And we also checked that the business model was a win-win. The results was incredible. There's a quote here by Robert Beshu, the CTO of Global Digital Supply Chain for Microsoft. He said we were facing increasing complexity, leading to increased inventories, increased markdowns, and lower service levels. We reached out to Golden Research Labs, and the outcome of that work had been nothing short of remarkable. We increased service levels by 5%, reduced our inventories by over $250,000 while reducing the lost sales by over $100 million. And you can see on the graphs there, the purple line was what the inventory levels were before and what it was with the new theory of constraints rules. A massive reduction in inventory while at the same time almost completely eradicating lost sales due to shortages. The second case study is one where we wanted to see a company that has made investments in these new Industry 4.0 technologies but weren't getting the value. Could we use the Procon Cloud method to get some additional insights from this? Well, why did they make the investment in the first place? Is that mining was lagging behind the S&P 500 in terms of shareholder returns. And that's important to know because you are not just competing against other mining companies, you're competing against other companies. And the same was true for their productivity. The productivity in mining companies was substantially below that of other companies, especially the high-tech companies like the Googles, the Facebook, Amazon, etc. So they believed that these new technologies would give them a potential not just to catch up, but maybe even surpass some of these more high-tech companies using Internet of Things, AI and big data, autonomous vehicles, blockchain, cloud and mobile computing, digital twins and simulation, quantum computing, and robotics. So what happened? Well, some of the technologies did have positive return on investments. However, by far the majority of the returns were slower or lower than expected. That put a lot of pressure on the business units that was funding these technologies. They were bitterly complaining and saying that these investments were not paying off, and the company's share price and returns were just not growing as fast as expected. So what was the conflict that they experienced? And we used the Procon Cloud method to represent this conflict, which is on the one side, they feel pressure to make changes to ensure the innovation results is achieved even faster. And that sometimes means not putting these new technologies through the very traditional and standard way of evaluating new investments, which traditionally in the mining environment is a process that is very long, takes very long, and is quite risk averse. Of course, if you take too long to decide who you're going to fund, you might miss out a complete opportunity. At the same time, there's pressure to keep on using the slower and safer approach that they've developed in the past to justify any investments in the past. Each of these approaches have both pros, but also some cons. The pros of making changes to go faster is that hopefully you can be recognized now as an industry and market leader in innovation and technology, but it also has a con. What if it causes you to make bad investments and you don't get a return on an assets? If you keep on using the standard approach, the no change part, you don't have to make internal changes. You can keep following the standard approach. One solution fits all. So it's more efficient, but it comes with a negative in that many of the high-tech investments that maybe should have been supported, should have been invested in, would not be approved. The goal of the company is to achieve a step change in safety, productivity, and returns. And their biggest fear is that they don't do that. And that essentially, not only they don't achieve the financial performance they believe should be possible, but they know they're competing also against other high-tech companies for attracting and retaining the top talent. What if they can't do that? So they realize with the Procon Cloud method that they need to find a way of turning the change option into a win-win. And the two assumptions that they have to challenge was that the standardized approach was in fact the best approach for all, that one solution fits all, and quickly realized that was simply not the case. They needed to make some changes to the standardized approach. And secondly, that the approach of going faster by supporting these high-tech companies would not be a risk if you are only investing in technologies that do really diminish the limitation, and you can figure out what rules to change. So you can get a technology investment that has a big upside if it works and a small downside if it doesn't. And that's essentially the solution that they developed, is to update their standardized approach to invest only in tech options that have a big upside if it works and a small downside if it doesn't. And it helps them to achieve all the positive without any of the negative. And the last example I want to present as a case study is the use of digital twins in very complex environments like a project environment, where you have a big portfolio of projects. And the question is, are you going to be able to reliably meet your commitments in the lowest cost way? And if not, what the conclusion was, our project plan's just too ambitious, we didn't have enough buffer, or could it be that we're simply using the wrong rules, the traditional rules in planning and executing these projects? Maybe we're releasing too many projects at the same time, or maybe there's still levels of multitasking or Parkinson's or unsynchronized priorities, etc. So a project portfolio digital twin like the one that Golden Research Labs have developed allows you to do all those hypothesis testing in a virtual environment that's low cost and low risk. So here's the project that they do. This company, they build condos. There's 4 phases to the project: design, foundation, construction, and finishing. The finishing phase can be done sort of semi in parallel to the construction phase. There's specific team members that's required. That this sheet lists the team members and the time durations that they use for planning. And it also shows how many team members they've got available. In most cases, they have enough available to be able to do 10 of these projects at the same time. And that's what their portfolio was, is to do 10 of them. So we read in this data, we added the expected variability and task duration into our project portfolio digital twin. It's called Project Portfolio Digital Twin, and it allows you to press the play button and see what's going to happen. So you've modeled your system accurately. You can check there's events that happen, and how do you respond to these events? Does it make it better or worse? Are you going to meet your commitments or not? We can read in the data. It shows that we've got 10 projects that we've read in. This is how they pipeline. They're all being done in parallel. Everything starts as soon as possible. The expected end date for our total pipeline is the 26th of June, 2021. And we expect to make about $800,000 or about 20% net profit on every condo unit that we deliver. And it looked from the resources that even though there's a small few spikes, overall, the average utilization is way below 100%. So we should be okay on the resources. So we read in the data, we can run different scenarios against each other. So our baseline scenario doesn't use CCPM, it uses traditional ways of scheduling the project, like start everything as soon as possible. There's potential for multitasking, unsynchronized priorities, etc. And in rounds 2, 3, and 4, we tried different CCPM mechanisms for controlling the WIP. Round 2, we tried controlling it by the last phase, so releasing projects and limiting it by the number of finishing phases, the teams that we have to do finishing, using that as the WIP control mechanism. Round 3, we used the number of projects as the WIP control mechanism. And round 4, we used a kind of a hybrid. And you click the play button, you'll see that we can model both perfect world and real world. Perfect world means that there's no task variation. So everything takes exactly how long it was planned to take. And the question is, will you be on time? Well, if you've considered all the capacity constraints, you should be on time. But if you miss some of them, or if you multitask that causes losses in capacities and delays, you will not be on time. Real world is where we fully consider the variability in task duration. So maybe we planned to complete the task in 20 days, but in reality, it can take 10 days as a minimum. The likely might be 16 or 18 days, but it could also take 30 days. So that's what we can do within the simulation model, is you can actually simulate that randomness and see whether the delays that you get is compensated for by the early finishes or not. And this is what the portfolio looks like if you execute them in those 4 environments, perfect and real world, for the 4 rounds. So round 1 without CCPM, you can see all the projects are late. None of them finished early. In round 2, many of them are finishing early. A few of them are late. The same true for round 3. And round 4 is when where everything is actually finished early. Inside of the digital twin, there's a lot of statistics. So you can see in this case, the variation by project. So whether it's late is above the line, how many days it was late, below the line is if that project was early. So you can get lots of insights very quickly from how the project portfolio would likely end with the rules that we've decided to use. You can also look at it from a Gantt chart perspective, and you can get full financials, because inside of our digital twin, we also read in when revenues will be recognized, when costs will be incurred, if the cost is variable or fixed cost. You can modify the number of resources in the simulation, rerun it again and see if that helps or not. And there's full analysis on the type of delays that's being caused and the resources. That is your main constraints, what resources are causing bottleneck. If you are interested in the financial performance, you might find this very interesting. The net profit in round one, which is essentially the baseline, what would have happened if they didn't make a change? They would have lost $1.2 million when they were expecting to make $800,000 per project. The best outcome was round four with a hybrid mechanism of controlling the WIP that would have given them $610,000. And of course, in the simulation, you can try other rules, you can try other mechanisms for controlling the WIP or for doing priorities. You can also add resources or take resources away and see how that will impact it. So those were the case studies I wanted to present. I will end up with this question of which parts of TOC should you use if you're an IT? Should you just be using CCPM, or are there other parts that are beneficial? I have presented a slide before to everybody, but just as a reminder, theory of constraints as a theory is a good explanation about why constraints are very important and useful. And knowledge of a constraint in the system, whether it's the constraint in your department for being able to do more work that is being demanded from you, or the constraint in the company or even in the supply chain, is very useful when it comes to making reliable commitments and making better, faster decisions. 5 big decisions that we make is how to set an ambitious but achievable goal. If you know the constraint and you know how much potential you lose that could have been avoided, you know how to set ambitious but achievable goals. You want to know where to focus your improvement and investments. Knowing the constraint helps you to do that, so you don't waste scarce resources improving something that is not the constraint. Being able to judge the impact of a local change, you can use the throughput accounting part, but also combining the simulation aspect, so you can see the system impact of local changes. What rules should we use? This is, of course, the main part of theory of constraints, is a set of rules for planning, execution, and improvement. And the rules are different if you're in projects or production. So CCPM is really just relevant for big project environments, but often there's hybrid environments that you should be studying what are the other rules to use, and then when to change the rules is when a constraint moves. If you want to keep the system stable so you don't have to change the rules, you can keep the constraint in one place. If you think about McDonald's, for example, how often are they changing the rules? Or almost never. Why? Because they assume the constraint is the number of customers walking into the shop wanting to buy. And they've created a set of rules in a way to always exploit that constraint and, if necessary, elevate it. I've included in the slides just a reminder that there's a difference between principles and applications. So CCPM is an application, Drum Buffer Rope is an application, Lean and Agile are applications, but they're all pretty much based on the same principles, which are the principles of flow. So the strategy is we want to be able to do more faster at lower cost. How are we going to do that? We're going to focus on improving flow and synchronizing flow. And we have 3 ways to be able to do that: the decisions we make in planning, in execution, and improvement. And this slide shows us what are the key decisions we have to make in each of these. For example, in planning, decision 1A is how do I allocate resources and how do I buffer? The mistake that we can make is highlighted in red in each of these. The conceptual mistake, for example, we misallocate resources on forecast or we buffer locally. And then in green is the principle that we can use, and that principle is adopted into the rules of CCPM, for example. So rather than allocate all the resources ahead of time, keep some resources back to benefit from aggregation, and only allocate it as it's absolutely necessary. So I'll leave you with this final thought, that there's nothing as powerful as an idea or a technology whose time has come. The idea that we are all passionate about is theory of constraints, and the way it helps us to improve, constantly improve very complex organizations and systems, help us to achieve a process of ongoing improvement. But there's also these digital technologies that are now available. I know many of your departments and companies are already benefiting from these technologies. The warning there is, make sure that the technology that you are adopting, this new technology, actually does overcome a valuable limitation. And even if it does, what were the old rules that were put in place to live with that limitation? Because unless you change those old rules, you might not get the full value. And that is the promise. It can bring incredible value to your customers, to your shareholders, to employees, if you adopt more of these technologies, but also learn more about how theory of constraints can help you make more reliable commitments and be able to do more work that is meaningful and important to help your organization survive and thrive into the future. Thank you very much for your time, and I look forward to any questions that you might have that comes up during the panel discussion.